these results will be from 2015 in context with our historical trawl series dating back to 1978. But there's also going to be a strong sense or presence of looking towards 2016 because we have a really nice setup with ice conditions that we've had in the past to the ice conditions or lack of ice that we have this year. So think about that as I'm going through this as well. So in 2015, these were the sites that we sampled. We have two main surveys, nearshore survey, which is the circled dots, the ring of pearls around the lake that we've sampled since 1978. The triangles is our offshore survey that we've sampled since 2011. And we hit most of the sites except for those few that are not colored in, and those are due to commercial fishing nets that were in place in the nearshore zone. In the offshore zone, we had a few technical problems with the ship that one day, and we couldn't get those two sites. This is the pot of gold that we were all hoping to find after that big ice year of 2014. So these are age 1 corygonids. And we found some. Did we find as many as we thought? We really didn't. But in historical context, that recruitment index, so this is the number of age 1 corygonids. Primarily these are all Cisco, but this data right here is for Cisco. Corygonids as a whole was around 30. That number is 14, and that's the same number as we found in 2009. Much less than previous years, but much better than we saw in the previous 5 years. And the same again as 2009. And that's important because right now this shows that same graph, but it's overlain with aging data from Minnesota in their catch to show where those year classes came from. And so 2009 fish is pretty much the majority of fish that are being caught right now. And it also shows how well our index tends to track future populations. So our emphasis the last several years has been what's the population status of Cisco and what's the recruitment bottlenecks. And you're going to hear a talk later today on adult spawner surveys that Mike Sider's giving. The age 1 data is based on our bottom trawl. And the last few years we've been collecting larval fish using surface trawls. And then this past winter we've also started to look at the egg stage. So we're trying to hit every single life stage to try to, again, look at status, being able to predict future populations, and then again trying to identify why recruitment is so variable or why we don't have recruitment in some years. And data from both what we've seen on Lake Superior and what they've seen in parts of Europe is there seems to be a strong relationship between ice conditions and age 1, our Cisco recruitment. And this plot shows Cisco age recruitment on the y-axis against the maximum % ice cover for that year class on the x-axis. Again, so as we increase the amount of ice cover in a particular year, we tend to get better recruitment, but it doesn't always hold. So you can see it's like 50% of the time, if the ice cover is greater than 65%, then we get a measurable recruitment event, but a lot of times we don't. And so there's something else going on. It's not just one thing, like everything in life. It's not just one thing. It's a combination of things that are probably occurring, and we don't know what that combination exactly is. Since let me go to the slide first. So since 1998, which was the last big El Nino year, there's been a dramatic change in the ice regime on Lake Superior. And so this plot shows back to 1973 to 1998, the average ice cover is about 73%. 1998 was that huge El Nino year, similar to the El Nino event that they're having this year. And since that time, the ice regime has changed. And so instead of getting a major ice year every year, now it's about 1 out of every 5 years that we get a major ice cover on Lake Superior. So it's that same plot, but it shows since 1998, right? And there's been very few years since then that we've gotten precipitable ice cover and very few years of recruitment. And 2014 is shown with 2009 right there in the bottom right. This is ice cover of 2014, so we almost got 100%. We got 97% cover, and this is for the 8th of March. And ice cover in 2015, very much the same thing, but they were very different in another aspect, in that in 2014 the ice tended to linger throughout the spring, and in 2015 it came off pretty early. And what this did is it changed the water temperature dynamics in the nearshore zone where those larval cisco were present. And so 2014 was the coldest year on record that we have measured, and then much colder than average. And 2015 was quite a bit warmer, in a sense like only 1 degree warmer, but that is quite a bit warmer than it was on 2014. So this set us up for a nice comparison in terms of larval fish dynamics. We collect these larval coregonets. We can't identify them at that stage. They're from 9 to about 25 millimeters, and they hatch at about 9 millimeters, and this corresponds well with laboratory hatch fish, and so we can pretty much get a good idea of the day that they hatch based on their length, again in comparison to what we see in a hatchery. And we collect these at all of those bottom trawl sites, so over 130 sites we were able to do this at. And this just shows the density and number of larval fish per hectare across all the sites that we sampled in 2015. So we're very capable of collecting these fish, and we think this is a lot of fish, but again, we don't know. We've done this in 2014 and we've done it in 2015. And those were also 2 big ice years. And so this next year, it's pretty exciting because it's a low ice year. So we're going to see a similar number, or is it going to be higher? Is it going to be lower? We don't know. The difference in water temperature was apparent in larval growth. So 2 things to see here is that, one, densities were higher in 2015 than they were in 2014. So that gives us hope for a recruitment event in 2015, right? Because we had a recruitment event in 2014 when we got high numbers of larvae. We had higher numbers of larvae in 2015 than we did in 2014. So we think that we're going to get another recruitment event of age 1 this next June when we go sample those age 1 fish. The second thing is we didn't pick up these larval fish until about 8 days later, 9 days later in 2015 as we did in 2014. And so we think that has something to do with the water temperature. And pretty much every site around the lake, numbers were higher in 2015 than they were in 2014. The highest sites that we measured was at the Baptism River site. These are actually daily averages, so it's an average of about 4 sites along that north shore, and it wasn't in the Apostle Islands, which we normally think of in terms of the highest densities of cisco or spawning cisco that occur around the lake. And then the eastern side of the lake, those were our lowest estimates, and that was the same in 2014 as it was in 2015. This is another way to look at that data in terms of where these fish occur in space. And this plot's both 2014 and 2015. And 2015 is the lighter color and 2014 is the darker color. And in general, the lighter color dot is bigger than the 2014 dot. And we collect them everywhere, right? And they're not spawning everywhere. And one of the issues, the good thing with this survey is we sample 130 sites around the lake, so we get a representation of where these fish are occurring around the lake. But the bad thing is we're moving every single day, right? So we don't know whether we're sampling, in a sense, the same group of fish. Those fish, if you think about it, could be moving with the ship. So we're sampling the same group of fish every single day, or is it these are discrete populations? And the spawning is not occurring like in the main part of the lake in the deepest water, but we're still picking up those fish. Again, these fish are only about an inch long, 25 millimeters, towards the end of June. So they're kind of at the mercy of wind and waves, so they're moving around. It does give you a sense, though, of where higher concentrations are around the lake. This is that same data, but this is looking at growth. And so we see the same thing that we saw with numbers. It was higher in 2015 than it was in 2014. So growth was, in terms of growth rate, was twice as high in 2015 as it was in 2014. And in lab studies, growth is about between 0.15 and 0.25. So if you feed fish as much as they will eat at that stage, that's going to be their growth rate at these same temperatures. That was work done at Michigan Tech by Otomari. And so its growth rate is less than you would see in the lab, but in 2015 it was not appreciably less than you would see in the lab. So again, that's encouraging that these fish may survive, and we'll see a recruitment event of this next June when we go out and sample. This is both our nearshore and our offshore to get a sense of overall biomass for all the fish. So this is bottom trawl data now, so we're shifting away from that larval Coregonus data and looking at our bottom trawl survey data. And the obvious thing to see here is how similar all our offshore sites generally are to one another, and how dissimilar the nearshore sites. So a lot of variability in biomass in the nearshore zone, very much less variability in the offshore zone. And the offshore biomass about 4 times higher than the nearshore zone. And that's typically what we see as well. The bars are the long-term mean, and the line is the median, and those are standard error bars. Again, so in 2015, total biomass was way down compared to what it was the 2 previous years, but it kind of fit that trend, and it fits the trend that we're seeing on all the lakes, and that overall biomass of fish is down compared to historic values. And to put this in perspective, there's 3 things going on here. It's the blue is the total biomass, so basically the plot you just saw. The gray shade is, if you sum up all the Coregonids biomass, and then the bars are the H1 density estimates. And so you can see that our total biomass on the lake it's all due to Coregonids. And so if we don't have a recruitment event of Coregonids, biomass declines appreciably. I think it drives home that point of how important Coregonids are in the lake in terms of overall biomass and the role that they're playing in the ecosystem, and how that may not be occurring when those levels get to the levels that they are now. This is the data for offshore. 99% of the fish that we catch in the offshore zone are either a Siskowet, a Kai, or a deepwater sculpin. So they make up 99% of the total biomass. Again, not much difference across years. It's down a little bit. And again, I think that's also related to that Coregonid biomass going down, where most of that is in Kai, and we have seen a decline in Kai over the years. Again, looking towards 2016, it'll be a big year for testing a lot of our thoughts on what we think controls recruitment of Coregonids. And so for adults, we're going to have a lake-wide acoustic estimate, and the last one we did was in 2011. And then next slide, I'll show you a little bit of data from that. For age 1, we had high larval densities again, and we had higher growth in 2015 than we had in 2014. But is that going to translate into higher survival to that age 1 size? We don't know. So it's, we can't wait to get out there. And in terms of the larval fish, those age 0 fish, right? What does this year of no ice have on them? Are we going to see similar numbers as we saw in 2014 and 2015, which suggests that if you have a similar number of spawners, they're releasing a similar number of eggs every year. So, and you have similar survival of those eggs. Is that number that we're seeing for larval fish, is that consistent through time, like regardless of what the winter conditions are? Is that bottleneck maybe something occurring between the egg and larval stage, so we're not even going to see those larval fish? Are they going to come up and they're only going to live a day or 2 and we're not going to see them at all? So right now our ship is frozen in the ice in Chequamegon Bay, so we can't get out, but it's open water season out there on Lake Superior. As you can see, this slide is from a few days ago, or the satellite photo in the bottom right is from a few days ago. So the lake is completely open, and that wasn't at all the case in previous years. So have those fish already hatched, or have they not? We just don't know yet. 2016 is also our CSMI year, and these are the sites that we will sample as part of the CSMI effort on Lake Superior, and these are the exact same sites we sampled in 2011. And it's a total food web approach where we try to sample everything from nutrients up to the top piscivore. And again, we'll do bottom trawls at all these sites, and we'll do acoustics at these sites along with midwater trawling. This will allow us to look at status and trends of the pelagic community, something that we can't do on an annual basis. And this is comparing 2006 to 2011 data. And there was quite a decrease in pelagic coregonid biomass between 2006 and 2011. We haven't had an appreciable recruitment event during that between 2011 and now. So are we going to see a similar decline, or is it going to, we don't know. But 2016, when I'm here next year, those results will be interesting. We're adding a new twist, so we're doing everything the same that we did in 2011, but we're adding next generation hydroacoustics to this year's sampling event, and this will allow us to collect lots of fine spatial scale data over vast volumes of water. And so for years we used to tow a towfish, and that's almost, and we put a transducer on the towfish and carry it behind tow it behind the ship, and that has limitations. And so then the next wave of technology was putting the transducer right through the hull of the ship, and so then you didn't have to have this overboard, you didn't have to stop and deploy it and undeploy it. And so that was like a huge leap, and we were so happy we didn't have to do this overboard. So now we've gone back. So we're going back, and we're going to, again, towing a towfish, but this is a more sophisticated towfish where it'll have 4 transducers at a time, and some will be pointing up and some will be pointing down, and they're at different frequencies, so we'll be able to hopefully quantify everything from zooplankton up to pelagic fish at the same time, at the same place. And we'll also be doing net tows at the same time at all these sites, and so we'll have both net estimates and to then scale our hydroacoustic estimates too. That's all I have today. Thank you.